Here's another tree on your list for week 3, or the 3rd list. This is the American elm. So there's a couple of small elms in here. We're again close to the power line on campus. Elm has kind of a loose, scratchy bark. It almost looks a little bit like the Australia. It forms layers, and the layers can get pretty thick, so it can have some fairly thick, corky layers. We will see some larger ones when we go into the floodplain forest as a group, and you'll see that more prominently. It has alternate leaves, simple, and as you can see, they're very coarsely serrated. So sharp, prominent teeth all around the margin of the leaf. The elm, we'll talk some more about the history of it. It used to be a very widespread tree in our eastern forest. Can tolerate being wet, so it's often in floodplains. Though it doesn't tolerate flooding per se, but it can tolerate fairly moist soils. So it was often in the river systems as well as in the uplands. We'll talk some about its growth form as well. It's a very rough and sandpapery texture. So if you were to rub the upper surface of the leaf, it's very sandpapery. If you rub it on your face, it's uncomfortable, right? It's that coarse on the upper side of the leaf. The other really distinctive characteristic is, if you can see where the leaf attaches to the petiole, right? So there's the center vein, or what's called the midrib on these leaves. And when you look at where the blade of the leaf attaches to the midrib, on one side of the leaf of the midrib, the vein attaches at a different point or the leaf attaches at a different point than on the other side of the midrib. That's called an asymmetric leaf base, or an inequilateral leaf base, where the blade doesn't attach to the midrib at the same point on either side. The other species that we have in this week's group that does that is the witch hazel. So witch hazel's also got an asymmetric leaf base, where the leaf blade itself attaches at different points on the petiole, or on the midrib. But as you remember, the witch hazel has that rounded or wavy leaf margin, and the American elm has this sharply serrated, large coarse teeth on the leaf margin. I'll show you them side by side. Get up here into the sun. Hopefully this will make it work better. So there is the elm, and there is the witch hazel, and you can see the same thing on the witch hazel. It has that asymmetric leaf base where one side of the leaf attaches to the petiole at a different point than the other side. Same thing on the elms, but again, the shape of the elm leaf is slightly different, and that really sharp, coarse teeth are a real distinction between these two species. And these were growing very close together, so it's conceivable you'd even find them in places where the branches are kind of intertwined on a small one. The elms have the potential to get to be 70-80 feet tall, whereas the witch hazel is always going to be that multi-stemmed shrub that's somewhere between 6 and 12 feet tall. But you may find small ones growing together where the branches are intermingled and need to tell them apart. Right, so again, the asymmetric leaf base, these are really the only two species we're going to learn where that's a diagnostic. There are a couple of other elms. The slippery elm we may also find that also has an asymmetric leaf base, but they're not as common in our area as the American elm. The witch hazel is really common, and even though it's an understory shrub, it's a good one to be able to identify.